Today, we will explore sigma, summation, notation, and its significance in mathematics. This concise notation simplifies the expression of the total sum of a series of numbers or terms. Let's get started. Sigma notation, also known as summation notation, is used to represent the sum of a sequence of terms. It provides a compact and efficient way to denote the total sum of a series, making mathematical expressions more concise and easier to work with. Let's represent an arithmetic sequence using sigma notation. Suppose we want to sum the first n terms of the sequence, where each term differs from the previous term by a constant value. This application of sigma notation in arithmetic sequences simplifies calculations and expresses the total sum succinctly. Next, let's represent a geometric sequence using sigma notation. In a geometric sequence, each term is obtained by multiplying the previous term by a fixed number known as the common ratio. Using sigma notation to sum the terms of a geometric sequence showcases the versatility of this notation in handling different types of sequences. Sigma notation is also useful in representing infinite series. By employing sigma notation, we can succinctly represent the summation of an infinite number of terms in a series. This capability is particularly valuable in dealing with mathematical concepts that involve an unending sequence of numbers. Learning to manipulate sigma notation is crucial for simplifying mathematical expressions. Techniques like simplifying the sum of the first n positive integers demonstrate the power of sigma notation in performing complex summation calculations more efficiently. Sigma notation finds applications in various fields, such as calculus, number theory, statistics, and computer science. Its adaptability and simplicity make it a valuable tool for mathematicians and scientists in expressing and manipulating series of numbers across diverse disciplines. Let's test your understanding. 1. Write the sigma notation for the sum of squares of the first n natural numbers. 2. Simplify the sum of a specific arithmetic sequence to practice manipulating sigma notation. 3. Represent a geometric series using sigma notation to apply your knowledge of sequences. We have covered the introduction to sigma notation, representing arithmetic and geometric sequences, infinite series, and practical applications and manipulation of sigma notation. Sigma notation emerges as a powerful and versatile tool in mathematics, simplifying complex calculations and aiding in a deeper understanding of series. Thank you for watching this educational video on sigma notation. We hope you have gained a clearer insight into its significance